Okay, so what we've got here is a three-part problem, and they're all going to kind of help you out with the third part, part C. So let's jump right into it. Let me share my screen. Okay, open up this. I was just getting a head start. Okay, so for part A, it's asking us, show carefully how to use the rule of logs to deduce that ln of x to the 3x plus 1 equals 3x plus 1 ln of x, where x is greater than 0. Okay, so really this is straight up one of the rules of logs that says that if you have log of x to the p, that equals, or log base a of x to the p, that equals p times log base a of x. So that's that exact rule there. So part B is saying giving full details of all steps, show how to use the product rule for derivatives to find the derivative of 3x plus 1 ln of x. Okay, so it gives us a big hint here. It talks about the product rule of derivatives. So the product rule actually states that dx of f of x, g of x, or the product of two functions, f and g, is equal to f prime of x, g of x, plus f of x, g prime of x. So in our case here, we could say that f of x equals 3x plus 1, and g of x equals ln of x, right? So when you calculate this out, you should just be able to do f prime of x and g prime of x, and I'll leave that up for you to do, but your final answer is basically going to be that. So then if we look at part C, it's saying show how to find the derivative of x to the 3x plus 1 by first writing it in a different exponential form and then using the results from parts A and B above. State which rules you use along the way. Okay, well first let's take a look at what we have here. We've got something in the exponent that's got x in it, and that's a little confusing because we have x to something in terms of x. Wouldn't it be great if we could somehow move this into the coefficient spot? Well, we just learned a rule how to do that. Log base a of x to the p equals p log base a of x, right? Where p here could be our 3x plus 1. So wouldn't that be great if we could say, I don't know, something like ln of x to the 3x plus 1, and that would allow us to move this right in front here, according to that rule. But we can't just say ln of x to the 3x plus 1, because that's not equal to what we have up here. But what we can do is say e to the ln of x, 3x plus 1, because ln of x to the 3x plus 1 just means what power do we need to raise e to get this? And we're raising e to that power. So let's just write out that, and that is perfectly legal. And then we could do that next step that we just said. So we have now 3x plus 1 ln x. Awesome. And that was using the rule that we just did in part A. So now that we have this, this looks a little hard to differentiate, but you may have learned this already, but there's a rule called the chain rule, which says that d dx of f of g of x equals f prime of g f prime of g of x times g prime of x. And in this case, f of x equals e to the x, and g of x is just the x here, which is our exponent. So 3x plus 1 ln x, right? So we could write this as f prime of g of x. What's f prime of e to the x? It's just e to the x. So we write this out. 3x plus 1 ln x times g prime of x. So g prime is going to be, how do we do g prime? Well, we have two things being multiplied by each other, right? So we got to use the product rule. So g prime of x, we actually got that answer in part B. So here, you're going to put your answer from part B. And before I get too ahead of myself, I want to make sure you got here on your own. So if this helps, please let me know. If you have any other questions, just leave a comment and I'll answer it as quickly as I can.